докладом. И сейчас я приглашаю на сцену Джина и Азура, которые расскажут нам о токенах в операционных системах Windows. Прошу поддержать их. Ребята приехали из Китая, так что...
Yeah. Hi, guys. I'm sorry I speak English. Yeah. So this time, my partner Azure and I will give you a presentation about Windows tokens. So first, let us introduce ourselves. Yeah. So my name is Daniel, and this is Ira. We are security researchers from King Team. And Ira is our intern. Actually, he is now still a college student. He seems to be one of the most dangerous students in China. But actually, it's just kidding, because our team are all white hats with moral disciplines. So we only use our research results for a good reason. Actually, we also encourage other hackers to share their research results and report them to the vendor to help make the world a more safer one. So let's talk about something about our team. Our team is King Team. Actually, it's not just only team. It's a company. So someone may get some misunderstanding about this. Our team has got 5 champions in the Pong2On and got 2 nominations for the Pony Awards this year. Our team has hosted the Geek Pong, which is the most influential security event in China for 2014 and 2015. So in this year's Geek Pong, many devices and services has been pwned. For example, the HTTPS protocol, the drones, the mobile phones, and some routers, and some web cameras. Many devices has been pwned. It's a wonderful party. So I hope that next year's Geek Pong, I can see some Russian faces. Welcome. So our team is a compact one, but we have more than 10% foreign members. Among them, the Peter Hlavati and Marco Grassi were speakers here. So this is the outline. For the first 6 items, I will give you the presentation, and Azure will do the rest.
Okay, so see you later.
Yeah. So when we talk about security, there should be something need to be protected. So these secureable resources exist in the form of objects in Windows. Why are the objects get protected? Because each object has a security descriptor attached to it. And this security descriptor describes the objects can be accessed by whom and how. And when we have object, so there should be something subject. What is the subject? So the subject is the process. More precisely, it is the thread. Each process have a primary token. And if the thread is impersonating a client, he may have an impersonation token. So when we doing the access check, we are saying that the the subject is an effective token, which means if the current thread is impersonating another client, it uses its impersonation token. Otherwise, it will use its precise primary token. So we have subject, we have object. So when the subject accesses the object, there should be some check to determine if the subject are qualified to do such access operations. So this procedure is called the access check. Actually, access check happens whenever an object is created or opened. And the result of the access check will be cached to the processes handle table. So processes handle table is very interesting one, and it's quite the same like the page table. I mean, it's multi-level, but only the bottom level contains the used for payload entries. And each entry contains a pointer to the object, and the access rights has been granted for this handle during the access check. So because the results has been cached, all subsequent operations upon the handle will not do the access check again, just query the cached results. It is for better performance. And we can see that objects and processes are all hierarchical. I mean, they are in tree-like hierarchy. I mean, most nodes have children, and they may have its parent, except for the root and the leaf nodes. So just in this case, and when an object creates its children, or when a process creates its children, by default, it just the child just inherits the security descriptor and token from its parent. So this is why in our system, we can see that most security descriptors and tokens are the same because they are inherited from its parents by default. And if you are familiar with the Win32 API, you may know, you may have experience calling the method create file and create process. But you rarely pass the parameter LP security descriptor to the create file function. So it means you just inherit from its parent. And also, you rarely use the create process as user function to create a process, which will explicitly specify and token. But you normally use the create process only, which means it just inherits the token from its parent process. OK, let's talk about the access check. Access check has different types of check. So the most common one is a DACL check. DACL is short for discretionary access control list. So actually, it's a submember of the security descriptor. So DACL will check the identity. If specified identity has the right has been granted or denied for some specific access. And actually, we have talked about token. In tokens, there are 3 SID groups. It's named respectively the SID groups and the restricted SID groups and the app container capabilities. So they are quite the same in structure, but they have different meanings. Both of all of these 3 SID groups will be checked against the DACL in the security descriptor. And only if all of these 3 check satisfied, it will let the check pass. Otherwise, it means just deny the access. So this is a DACL check. And for the privileges and the super privileges check, what is privilege? It is quite different from the DACL. A privilege is not meant to guard any specific object, but to guard the system as a whole. And what is super privileges? Super privileges means if you got one of them, you can have the potential to control all over the system. But I use the word potential because you may still need some work or techniques to achieve such effect. And integrity level check and trust level check, I will talk about these 2 types of check later. So what is restricted tokens access check? So restricted tokens, I have said it belongs to one of the 3 SID groups. Actually, it is exactly a copy of the normal SID groups, but only with some SID disabled. So if a token has a restricted SID groups failed, it means its power is restricted, it's limited. And app containers capabilities is the third one of the SID groups. So what does capability means? If you have experience with Android system, it is quite similar to Android system, such as when you install an app, it will prompt you for allowing specific capabilities. For example, to access the night, access your location, such like that. So the app containers capabilities is just their counterpart in Windows, and only bringing when the Windows app has been introduced. Okay, so let's see the structures of token. Actually, I will first make some explanations. During my subsequent presentation, there will be many such graphs, but little text. I will just explain it to you. And another caution is the offsets. You see the offsets are just extracted from the Windows 10 64-bit. So this offset may be maybe differs in other versions of Windows. First, let's see the ePrecise. ePrecise is the kernel data structure for representing a precise, and it contains a pointer to a token. This is a precise's primary token, and the first thread, if it is impersonating another client, it will have a token. It's just the impersonation token. So in a word, the primary token is stored in the structure of precise, and the impersonation token may be stored in the eThread structure if it is impersonating another client. And let's see the top graph. It is just saying that one thread in the top precise is impersonating the low precise. What does the impersonation mean? It's just the thread want to act exactly as the low precise's primary token. But this may bring in some risks. So there is a field named impersonation level will be used to restrict the further use of the impersonation token. For example, if we want to duplicate it and want to create another process with it, there will be some restrictions upon this. And James Forshaw has discovered this in detail in his talk, A Link to the Past. Okay, this is the token layout. So actually, token is very complex. It contains all the information needed to identify the current precise, identify its capabilities. So now we only choose several very important fields. For example, the privileges. Privileges is, we have talked about these privileges. It's just a bitmap, actually 3 bitmap. So the number of the privileges is limited. And so it can be represented by a bitmap of one integer. So there are 3 bitmaps. One is the present. The others are enable and enable by default. Actually, this embedded bitmap does not be protected at all. It means you can directly modify it from kernel mode. But from user mode, you can only modify the enabled bitmap. You cannot modify the present. It means you can enable or disable a privilege that is present in your token. But you cannot add more or delete some of them from the present bitmap. But finally, whatever, because we can modify this from kernel mode. It is it is still easy to manipulate. And the subsequent three are just the SID groups I have talked to you. You see they share the same data structures, and you see the word hash because they are protected by a hash algorithm. It means if you modify the SID groups from kernel mode, it will fail if you does not update its hash. I will talk about this hash algorithm later. So the last member is the trust level SID. So let's see the last one. We can see that in process, that's a byte named protection. It is used for protected process. And here, the trust level SID is just the cache of the process's protection byte. Why it needs such cache? Because the token can be duplicated across different processes. So it must synchronize the current token's byte with the current process's protection byte. OK, so this is one of my open source projects. During this talk, I will give you another open source project related to token. And this one is an user mode application. It can obtaining, dumping, or modifying a token from user land. So obtaining means you can specify a PID, process ID, of a process, and you can get the primary token of it. If you specify the thread ID of a thread, if the thread is impersonating another client, you can get the impersonation token. And then you can dump the token just like this. Actually, this is a quite small one, because it's only a quite small part. So you can try it yourself. It's very interesting. So this is the algorithms of the SID groups hash. I have to say to you that this is my work just to reverse it and to rewrite it in C++. So here, it may not so accurate as the original implementations, but actually I just want to show you the demo it to you. So there are two characteristics should be mentioned. The first one, you can see that it only checks the first 64 entries in the SID groups. It means if you have a token which has an SID groups of 64 entries, and you calculate the hash of it, and you add another one to the end, you recalculate the hash. Actually, it's the same. Yeah, because this is the limitation of this hashing algorithm. And the other one is you can see that each SID, it will only use the last sub-authority to do this calculation. So what I mean is this algorithm is quite simple. If you want to modify the token directly from the kernel mode, you can first modify it, then you update the hash with this algorithm. It works. Although the SID groups are protected, the protection is also so weak. OK, let's see this. This is a very interesting part. If you have experience from Windows XP, update the OS to the Vista or later, you may have this experience. It is very annoying when you're doing some sensitive operations, for example, install and software or modify the system-wide configurations. It will prompt you a dialog box, ask for your confirmation. And this is called elevation. Why it will have elevation? Actually, this is a very important security features bringing to the new Windows version. So if you are familiar with Linux, you may know the sudo. Yeah. So it's actually quite the same as sudo. It just needs your confirmation or just a hint to tell you that the system are going to be changed with some sensitive data. So it's quite important. And how does this being implemented? Actually, if you are a user with the administrative rights, when you log on, actually there are two tokens has been generated together. One is the restricted one. I mean, what does restricted mean? It has disabled the SID for administrative rights. We can see here. Yeah, here for the last column, you may find the word deny only. Actually, this is an attribute of an SID. What does deny only means? It means it does not effective in the restricted token, but if this attribute has been removed, it is a full feature token. So actually, the two tokens generated, one is a restricted one, and another is a full feature token. So for normal operations that does not involved in the administrative rights, it just use the restricted one. And for some operations, for example, the sensitive ones that will modify the whole system, it will prompt to you. And after your confirmation, the process will use the full feature token to continue the following works. And there's another problem. How does the system find the full feature token for the restricted one? Actually, you can see the token. There's a field named logon session. Logon session has some members, logon ID, body logon ID. So its body logon ID is an index into a global table named as EP logon sessions. So it can find its related full feature token here. Actually, in this SEP logon sessions, there are many pairs, but actually there is some that is not that does not have a pair. For example, the token for the system rights, it does not have a pair. And there's another case. So it means OTS UAC. That's that's confusing. So what does OTS means? So if you are in a quite large firm and your firm has very restrictions on the use of your office computers, if you want to install a software, you may have to ask your boss to tap his passwords to let you go. So this is the OTS means over the shoulder. So you just sit here and your boss over your shoulder just have the password and then get the token. So for this case, the token is not generated when you log on, but generated after your boss have tapped his password. Okay, so we have talked about token. Then let's talk about the object. I have mentioned that object is very important representations for secure resources. This is the layout of an object. So it may have three parts. The first one is the object header, the middle one, object header, and then is body. And in some cases, the object may have a variable part header. I will talk this later. And in the object header, there's a pointer pointing to the security descriptors. The security descriptor contains the DACL. Yeah. So if this pointer is null, it means the object is not protected at all. It means everybody can access it without a check. So the body, what does the body mean? If this is a process object, it is just the buffer that contains the e-process structure. If it is the file object, it is the buffer, exact buffer that contains the file object structure. So let's see the layout of a security descriptor. So if it has file fields, the first field control determines if the buffers pointed by the following four members are embedded in this large structure or just pointing to some independent buffer. So if it is embedded in the continuous big structure, the subsequent four fields are just 1 byte offset. If it is pointing to independent buffers, so the four members are pointers. And the owner and the group are pointers to SID. The SACL and DACL, SACL means system ACL. DACL means discretionary ACL. So they share the same structure. It is ACL. ACL contains a varied numbers of ACEs. So in ACEs, it has header, mask, and SID. In the header, for DACL, in the header, it contains tabs. For DACL, the tabs can be allow or deny. And for SACL, the tab can be audit, can be integrity level or trust level. And the mask determines the access rights bitmap that is meant to allowed or denied. SID is just the buffer of SID. So this is the case of an object that has a variable header. So actually, in this case, it has this object is a named one. So actually, in most cases, the object is unnamed. Why does the object need to have a name? It happens when you share the object across different processes. So you may need a name. And the InfoMask field is used to index into the global table to find a negative offset where you can find the variable header. So there's name. Where does the name stored? Actually, it is stored in global object namespace. So actually, this namespace is quite the same like the file systems. It has structures. So for this one, the first object has name. And in the name info, it also has a directory pointer which points to the second object. It means the first object's parent is the second one. And in the second object, you can also find the hash buckets. You definitely will find some pointers pointing back to the first object. So this is how the global named namespace has been organized. So actually, there is some types of attack that is oriented to the symbol link. Actually, symbol link does not only exist in file systems, but also exist in the global object namespace. It's just this namespace. OK, so let's talk about the object type. This is a quite interesting one. So prior to Windows 10, a field named type index is used directly indexed into the global table, OB type index table, to get the type object. Why does the object need a type object? So the type object is some common members of the same type of object. And you can also see that there is some procedure pointers stored in the object type object. Why does we move out this info after the object. It is for security reasons and also for performance reasons. It can save space because the objects of the same type only keep one copy of the type object. It is also for the security reasons. If you just store the raw pointers directly in the header, you can buffer overflow the body, and then you can manipulate the pointers. That is very dangerous. So actually, in Windows 10, this process has been enhanced. The type index does not directly index into the global object table. It has an encryption. The encryption uses the XOR, and it has 3 factors. The first one is the field stored in the object header as type index, and the second one is the pointer. Actually, it's the second least significant byte of the address of the object header. And the third one is a global variable. It is only a byte. So the XOR will compute it upon these 3 bytes to get the real index. This real index index into the global table to get the type object. Wow, that's why we need this. So actually, why we need 3 factors for this. For example, if I just use the type index, actually, why does we need this? Because this small byte is quite crucial to an object. It determines the type of the object and determines what method can be used upon this kind of object. So if you modified the type index from a file object to a process object, then you can use the processes, for example, the open routine upon this file object. That could be introduce some problems. So this mechanism is called the type confusion. So this encryption is just to introduce to solve this problem. Okay, this is the second open source object I will present to you. So you can find the address. You can find the URLs. It's managed in the GitHub. This object is a WinDebug extension. It is used to extracting token-related data from kernel mode. Actually, it's when you're using WinDebug to debug the kernel. So I hope you can try this because this is very interesting. You can get different data out. So let's see this. This information is dumped from all of the active processes. And you can see that for the last 2 columns, this is the protection, just the trust level as ID. I have talked to you that. OK, so let's talk about the protected processes. So protected processes is a mechanism that is used for protect a process's contents from being modified or read or write or being killable. So this routine will be checked against these global data structures. And so these rules, I will introduce these rules. So if the host process is the kernel mode host, it does not. It just let it go. And if the target not protected, it means the protection byte in the process not is 0. It means it does not protect it. And if the host is the protected process, it just let it go. If they are of the same type, it means the protected process light. It will do the domination check. And the result of it, if the host process should be subject to the limitations, it only can get the following access allowed access. So actually, you can see that when you debug a process or when you create a process, this check will be happen. So this is the sandbox. The sandbox. This sandbox is based on the integrity level check. Actually, this is the most simple and effective sandbox. So the integrity check is very simple. First, the token's integrity level will be checked against the security ones. And the default security level of the token is untrusted. And the default for the object is medium. So it means most resources are in the integrity level of medium. And for some sandboxed processes that is run in low IL cannot access such resources. So there are other different types of sandbox, the app container 1 and the trust level 1. So the trust level 1, I guess it should be the third types of sandbox. And you can find some resources that is protected by the trusted level. OK, so that's my part. And I run. 没有多少时间，没有多少时间。
Okay. So he spent too much time. Hope you can keep up with me. So let's have a look at current day's browser in Windows 10. Current day's browser sandbox have multi-process, the broker process and render process. For example, in Chrome, there's a broker parent process and other render process run in entrusted level low. Plugin run under entrusted level. The render process is run under integrate level untrusted, and the plugin run under integrate level low. In Internet Explorer 11 product mode, there's a broker parent process and render process run in low integrate level, and in enhanced protect mode, its render process is in API container integrate level. In Edge browser, its render process is started by runtime broker in API container integrate level, and the parent process also started in API container integrate level. And also, there's a browser broker to deal with the things the render want to, but cannot achieve by its own. In Internet Explorer, it's IE shames here to do all those compatibility work in sandbox. In Edge browser, it's eShame to realize this function. The compatibility shames hook a lot of function. It hijacks the no more call to system API and redirects it to the broker process. Most of this API will not function properly if it because it is in the sandbox. Shames will do the parameter check according to the elevation policies to determine whether it should be forwarded to the broker. And in broker, it will check again according to the elevation policies. Shames check might pop a dialog to ask the user to check again. Ask the user if I should allow this option to run. And IE shames hook more than 200 functions. Compared to that, eShames in Edge only hook about 7 functions. Render process call no more function, and shames engine transfer it to higher level broker process through interface. The service that come here it is the broker. Always do some check or just impersonate the client side token to drop down the thread privilege to make sure it's security enough. And when the procedure is over, they call return to self to return the thread privilege. As Daniel mentioned before, in the kernel, there's a flag represent if the thread is impersonated. And if it is, the kernel will going to use the Clang security token. So I start to research in sandbox bypass in this year's January. I don't have a deep understanding of Windows security model that time, and I just have had a lot of stupid try to achieve logic sandbox bypass. After many fail, I focused on reviewing last year's CVEs. The last year have lot of browser sandbox logic bypass way, which I was very interested in. So I take a look at this attack method, try to find new sandbox bypass method in this function, which have logic sandbox bypass before. The problem was in the Adobe Flash Broker. As you can see, it is a part of broker create file function in Adobe Flash Broker. And in the past time, GenSocial found a CVE in it, failed to check if it's the symlink there or a valid directory. I check all the relation code in Adobe Flash Broker and find there's still some trick you can use to bypass the symlink check. If you are very familiar with Windows API, you will find out there's API usage is wrong. First, they use create file by this mode. You can see the share mode is 0. That means they don't want to share this directory with anyone else. So you just open a share read access, and it will and the broker open will failed because they don't want to share it with anyone. The broker process will do this file can't be open, so I think the node is not a symlink path. So it seems Adobe's programmer who wrote this broker is not so familiar with Windows API usage. Okay, so we can just use some trick to let the broker can't get its handle, and it will think the path is real. It's not a symlink. And there's another bug on the first line. As you can see, it uses splash to split the path. And on Windows, a reverse splash is also valid. So you can just convert your splash to reverse splash and pass to it, and it will fail to validate the path again. After I heard Daniel's topic about Windows security model, I think as for Adobe's programmer abuse of Windows API, I guess they must not familiar with Windows security models. I can't fix that. They can't fix that problem probably. So I checked the Adobe broker code again, and as you can see, this time it's not easy to bypass. But is there any more elegant way to detect recurse point file and etc.? Just it is just you can use get final path name by handle. But all this is based on open handles, and I'm the owner of the directory, so it's my file. Don't touch it. But how to do that? Did anybody have any ideas? If you set ACL to the malicious path, strip current users all access to this path only. Yes, you can use SDDL or just call CCLS to command line to set its to strip its privilege. Any access to this directory by current user will be rejected, but the file under this path can be write. I wrote a test program to exploit that time, and I succeed. But when I reboot the system and install the kernel upgrade, I failed to bypass sandbox because Microsoft published its MS-15 090 path just 1 day ago. Bypass the symlink mitigation from Windows 10. At its RTL, a sandbox token check if the process is sandboxed. And if it is, the system just rejects the symlink creation. No, not this phase. What cool and wise decisions they made compared to fix a lot symlink bypass bug. They fix it in kernel. And finally, I'll talk about how to make use of Windows Sandbox. It may not help you out from really bugs, but it is indeed a wise option for mitigation of potential attack. So the general thing you can do is assign a limited job object to it, modify file ACE to make sure they can access the file master use, and call process mitigation policy to reduce attack surface, and call create process to create new process assigned to the limited token and job object we just created. And finally, to assign a low IL to in case the bugs we will face when set it before program start. Here is a good self-made sandbox starting case. This GitHub link. Not necessary too complex, just for fun and most creative. So that's all. Is there anybody who have problems? Come on.
Are there any questions?
Thank you for your listening
Thank you.
to our speaking.